At 08:32 on the morning of October 14, 1943, American bomber crews across eastern England were preparing for a mission that would become one of the bloodiest days in the history of the United States Army Air Forces. The morning air was cold and damp. Fog had blanketed the airfields across eastern England during the night. Ground crews had been working since 0400 hours, fueling aircraft, loading bombs, checking engines. The smell of aviation gasoline hung heavy in the pre-dawn darkness. From dozens of airfields across East Anglia, 291 B-17 flying fortresses were starting their engines. The rumble echoed across the countryside. Crews climbed aboard. Pilots ran through their checklists. Co-pilots verified instruments. Bombardiers checked their bomb loads. Gunners fired their weapons. Radio operators tuned their frequencies. The routine was familiar. The tension was not. Most of these men knew they were flying into a death trap. The 351st Bomb Group at Royal Air Force Polebrook was part of the massive force assembling that morning. 41 B-17s from the group were preparing for the mission. The crews had been briefed at 0500 hours. When the intelligence officer pulled back the curtain, revealing the red ribbon stretching deep into Germany to Schweinfurt, the room filled with groans. Everyone knew what Schweinfurt meant. The 8th Air Force had attacked these targets 2 months earlier on August 17th. That mission had cost 60 bombers and 600 men, the highest loss rate of any mission to date. Now they were going back. The briefing officer explained the rationale again. Schweinfurt produced over 40% of Germany's ball bearings. These were critical components for every piece of military equipment. Destroy the factories and German war production would be crippled. The target was vital. The mission was necessary. The cost would be high. For the past 5 months, bomber crews flying from England into Germany had faced increasingly deadly opposition. Empty bunks appeared in the Nissen huts with disturbing regularity. Crews who flew out in the morning sometimes did not return in the evening. Personal effects were packed and shipped home. Letters arrived from families asking about sons and brothers who would never write back. The statistics were brutal. By October 1943, the 8th Air Force calculated that bomber crews had only a 35% chance of surviving their required 25 missions. 2 out of 3 men would become casualties. Every crew member knew these numbers. They lived with them every day. The target was Schweinfurt, Germany, ball-bearing factories deep inside German territory, 390 miles from the English coast. More than 6 hours in the air, the city contained multiple ball-bearing plants operated by Vereinigte Kugellagerfabriken, known as VKF and Fichtel and Sachs. Together, these facilities produced an estimated 42% of Germany's entire ball-bearing output. Ball bearings were essential components in virtually every piece of military equipment. Tanks needed them for turret rotation and track systems. Aircraft needed them for propellers, landing gear, and engine accessories. Submarines needed them for periscopes and torpedo tubes. Artillery needed them for traversing mechanisms. Trucks needed them for wheels and drivetrains. Without ball bearings, German war production would grind to a halt. The problem was not the importance of the target. The problem was getting there and back alive. The mission profile was simple and brutal. American P-47 Thunderbolts would escort the bombers as far as the German border, perhaps 50 miles beyond. Then their fuel would run out and they would have to turn back. After that, the bombers would be alone for approximately 3 hours, 200 miles deeper into Germany to the target. The bomb run over Schweinfurt, then 200 miles back out until fresh P-47s could meet them near the border for the final leg home. 3 hours without fighter protection. 3 hours during which German fighters would have free access to attack the bomber formations. Alone meant facing Messerschmitt 109s and Focke-Wulf 190s without any friendly fighters to drive them off. Alone meant the Luftwaffe could organize mass attacks, refuel and rearm at forward airfields, then attack again. Alone meant watching bombers explode and fall while having no way to help them. Alone meant dying. The 8th Air Force had tried this exact mission before. On August 17th, 1943, exactly 2 months earlier, they launched what was called the Double Strike mission. The plan looked brilliant on paper. Hit 2 critical targets simultaneously to split German fighter defenses. 376 B-17s would take Tarsem off. 146 bombers from the 3rd Bombardment Division under Colonel Curtis LeMay would strike the Messerschmitt factory at Regensburg, then continue south to land at bases in North Africa. This would be the first American shuttle bombing mission. 230 bombers from the 1st Bombardment Division under Brigadier General Robert Williams would hit the ball-bearing factories at Schweinfurt and return to England. The theory was sound. If both forces crossed into German airspace nearly simultaneously, the Luftwaffe would have to divide its fighters. Neither target would face the full weight of German air defenses, but the mission failed from the start. Dense fog blanketed the airfields where the Schweinfurt force was stationed. Visibility dropped to less than a quarter mile. Bombers could not see to taxi, let alone take off in formation. The mission was delayed. 1 hour passed, then 2, then 3. The Regensburg force at different airfields where fog was lighter took off on schedule and crossed into German airspace by mid-morning. German radar tracked them immediately. Every available Luftwaffe fighter unit in occupied Europe scrambled. The Germans threw everything at the Regensburg force. Hundreds of fighters attacked in waves, but LeMay pressed on. His bombers fought through the defences, bombed the target, and continued south toward Africa. They had done their job. By the time the Schweinfurt force finally got airborne and reached German territory in early afternoon, everything had changed. The German fighters that had attacked the Regensburg mission had already landed at forward airfields. Ground crews worked frantically. They refueled aircraft in 15 minutes, reamed them in another 10. Fresh pilots took over from exhausted ones. Mechanics patched bullet holes and replaced damaged parts. By 2 in the afternoon, when the Schweinfurt bombers crossed into German airspace, waves of German fighters were waiting for them, rested, rearmed, and ready. The element of surprise was gone. The split defences never happened. The Schweinfurt force faced nearly the full strength of the Luftwaffe. The attacks were savage and coordinated. Messerschmitt 109s came in from the front in formations of 4 or 5 aircraft. They flew directly at the bomber formations at closing speeds over 500 miles per hour. They held fire until they reached 300 yards. Then they unleashed everything. 4 20mm cannons and multiple machine guns firing simultaneously. The combined firepower at that range could saw a B-17 in half. German pilots knew that head-on attacks gave bomber gunners only 2 or 3 seconds to line up shots before the fighters flashed past. The approach was nearly suicidal but devastatingly effective. Focke-Wulf 190s attacked from the sides and rear, concentrating their fire on engines. The German pilots aimed specifically at the outboard engines. If they could knock out both engines on one wing, the bomber could not maintain altitude or keep up with the formation. Physics took over. An asymmetric bomber with 2 engines on one wing and none on the other could not fly level. It would roll, spin, and fall. A damaged bomber falling behind the formation was doomed. Other fighters would swarm it like wolves on a wounded animal, hitting it from every angle until it went down. The slaughter continued for hours. 60 bombers were lost that day. 24 from the Regensburg force, 36 from the Schweinfurt force, 600 men. Some died instantly when their aircraft exploded, torn apart by cannon shells hitting fuel tanks or bomb bays. Some burned to death as crippled bombers fell in flames, trapped in aircraft that became flying coffins. Some bailed out successfully but were captured immediately upon landing, spending the rest of the war in prisoner camps. Some died from wounds during the long trip to those camps, bleeding out in the back of trucks on rough roads. Some fell when their parachutes failed or were shredded by shrapnel. Some drowned when they came down in the North Sea, and rescue never arrived, freezing in the water while waiting for help that never came. The survivors came back to their bases in England that evening and told intelligence officers the same thing. We need fighter escorts all the way to the target and back. We need protection for the entire mission. Without escorts deep into Germany, we are being slaughtered. The intelligence officers documented every statement. They recorded the details of every attack. They compiled lists of missing crews. Group commanders wrote detailed reports. The reports went up the chain to 8th Air Force headquarters at High Wycombe. The conclusion was unavoidable and brutal. Daylight strategic bombing without long-range fighter escort was failing catastrophically. But there were no long-range fighters. That was the fundamental problem that was killing American bomber crews every single day over Germany. The technology simply did not exist in service with the 8th Air Force in mid-1943. The Republic P-47 Thunderbolt was an excellent fighter aircraft, one of the best in the world at high altitude. It was fast in a dive, reaching speeds over 500 miles per hour. It was heavily armed with 850 caliber machine guns, 4 in each wing, that could destroy any German fighter with a concentrated burst. It was incredibly tough, built around a massive Pratt & Whitney 18-cylinder radial engine that could absorb 20mm cannon hits and keep running. It had self-sealing fuel tanks that could take multiple bullet hits without leaking. It had armor plate protecting the pilot from ground fire and fighter attacks. American pilots loved the Thunderbolt. They called it the Jug because its stubby fuselage looked like a milk jug with wings. In combat, it could outrun German fighters in a dive, absorb damage that would destroy lighter aircraft, and deliver devastating firepower. But the P-47 had one fatal weakness that no amount of pilot skill or courage could overcome: range. With only internal fuel tanks, it had a combat radius of approximately 225 miles. It could fly that far, fight for perhaps 15 minutes, and return to base with minimum fuel reserves. That was barely enough to reach the French coast. It was nowhere near enough to escort bombers deep into Germany. Engineers had developed external drop tanks that could be mounted under the wings. These disposable tanks carried additional fuel that could be jettisoned when empty or when entering combat. With drop tanks, the P-47's range increased to over 450 miles. This was a significant improvement, but it still was not enough. Schweinfurt was 390 miles from England. Berlin was 560 miles. Munich was even further. The P-47 simply could not fly that far, fight, and return. The Lockheed P-38 Lightning theoretically had better range. With drop tanks, it could fly over 450 miles on paper. The twin-engine design meant more fuel capacity built into the twin booms. It also provided the safety of having 2 engines for long overwater flights. If one engine failed, the pilot could fly home on the other. On paper, the P-38 looked like the perfect solution to the escort problem, but it had catastrophic problems at the altitudes where combat occurred over Germany. Above 25,000 feet, the P-38 became nearly unflyable. The engines would quit without warning. Spark plugs would foul in the extreme cold. The supercharger intercoolers would ice up, causing sudden engine failures that could not be corrected. The control cables that ran through the twin booms to the tail would contract and sometimes freeze, making the aircraft nearly uncontrollable. Pilots reported that trying to fly combat in a P-38 above 25,000 feet was not just difficult but extremely dangerous. Since German fighters operated routinely at 30,000 feet and often attacked from even higher altitudes, this made the P-38 vulnerable and nearly useless for high-altitude bomber escort over Germany. The aircraft worked beautifully at lower altitudes. Most P-38 squadrons were reassigned to the Mediterranean and Pacific theaters where they could operate at 15 to 20,000 feet with great success. In those theaters, the P-38 became one of the most effective fighters of the war. The British Royal Air Force had tried daylight bombing early in the war and learned through bitter experience that unescorted bombers suffered catastrophic losses. German fighters tore them apart. The RAF switched to night bombing by 1941. Darkness provided protection that fighters could not. The Americans, however, believed they had developed a solution to the daylight bombing problem. Their doctrine said that heavily armed bombers flying in tight combat box formations could defend themselves through massed defensive firepower. Each B-17 Flying Fortress had 1350 caliber Browning machine guns, 2 in the chin turret under the nose, 2 in the powered dorsal turret on top of the fuselage, 2 in the ball turret underneath, 2 in the tail turret, 1 flexible gun in the radio room position, 2 guns at the waist positions on each side of the fuselage, 2 guns in the nose, operated by the bombardier and navigator. That was formidable firepower. 13 guns per aircraft, each capable of firing 800 rounds per minute. That was 10,400 rounds per minute from a single bomber. A standard combat box formation consisted of 18 bombers arranged in staggered layers. High squadron flying above, lead squadron in the middle, low squadron below. 6 aircraft, in each squadron, positioned so their defensive fields of fire overlapped. The theory was mathematically elegant. A German fighter attacking this formation would face fire from multiple bombers simultaneously. 18 bombers meant 234 guns total. The combined firepower should be sufficient to drive off or destroy any attacking fighters. American planners ran the calculations and concluded that the self-defending bomber formation was viable. The B-17 could fight its way to any target in Germany and fight its way back. The reality over Germany in 1943 proved this doctrine catastrophically and bloodily wrong. German fighter pilots were experienced, well-trained, and innovative. They had been fighting continuously since 1939, 4 years of constant combat. They had learned from fighting the Royal Air Force in the Battle of Britain. They had learned from fighting on the Eastern Front against the Soviets. They had studied American tactics and formations. They knew exactly how to attack B-17 formations to minimize their exposure to defensive fire while maximizing damage to the bombers. First, the Luftwaffe identified precisely where the B-17's defensive fire was weakest. The nose had only 2 flexible guns operated by the bombardier and navigator. These men were not trained gunners. Their primary jobs were navigation and bomb aiming. The guns were secondary weapons they operated when necessary. Attacks from 12 o'clock high, directly head-on and slightly above, gave those gunners perhaps 3 seconds to track a target and fire before the fighters closed to point-blank range and flashed past at combined closing speeds exceeding 530 miles per hour. At that speed, even experienced gunners had almost no time to properly lead the target. The bombardier and navigator had virtually no chance. Second, German fighters attacked in formations rather than individually. 4-2, 8 fighters would approach in line astern, flying nose to tail. Only the lead fighter faced the full concentration of defensive fire from the bomber formation. The trailing fighters could aim at bombers that were already damaged or distracted by defending against the lead fighter. This tactic multiplied the effectiveness of each attack pass. By the time bomber gunners tracked and fired at the lead fighter, the second and third fighters were already firing. The formation attack overwhelmed defensive fire. Third, the Luftwaffe developed specialized bomber-destroyer units called Sturmgruppen. These assault groups used Fokker-Wulf 190 fighters that had been heavily modified. Extra armor plating protected the cockpit and engine. The standard 20mm cannons were replaced with devastating 30mm cannons. These weapons fired explosive shells that could destroy a B-17 with just 3 hits. The heavily armored fighters would close to point-blank range, sometimes within 50 yards of the bombers. They would absorb defensive fire that would destroy normal fighters. Then they would open fire with the 30mm cannons at ranges where they could not miss. The results were catastrophic for the bombers. Fourth, German fighters learned to identify and systematically target damaged bombers. If a bomber had an engine smoking or feathered with its propeller stopped, if it was falling behind the formation, if it showed any sign of being crippled, the Luftwaffe would concentrate multiple fighters on it. A straggler had no chance. Once a bomber fell out of formation, it lost the overlapping protective fire from the other bombers. German fighters would attack it from multiple angles simultaneously until it went down. This tactic was brutally efficient. By October 1943, the numbers told a grim story. Bomber crews faced impossible odds. The 8th Air Force calculated survival statistics and the results were devastating. 2 out of 3 men would become casualties before completing their required 25 missions. These were not abstract statistics. These were fathers and sons. These were brothers and husbands. These were young men who had volunteered to serve their country and were dying in the skies over Germany at unsustainable rates. On the morning of October 14th, 1943, 291 B-17s took off from bases across eastern England. The force assembled over the English Channel and set course for Germany, climbing to 25,000 feet. At that altitude, temperatures dropped to -40 degrees Fahrenheit. The crews wore heated suits, but the cold still penetrated. Oxygen masks froze. Moisture from breath turned to ice. When men were wounded later in the mission, their blood froze before it could be properly bandaged. The first friendly fighters appeared over Holland. 74 P-47 Thunderbolts spread around the bomber formation in a protective screen. The fighter pilots knew they would stay as long as fuel lasted. Not as long as the bombers needed protection. As long as fuel lasted. The formation crossed into German airspace at 10:40. Radar stations tracked them immediately. Luftwaffe fighter units across Germany scrambled. Ground controllers vectored fighters to intercept positions. The trap was being set. At 1100 hours, the P-47s waggled their wings in salute and turned west toward England. Their fuel was running low. They had no choice but to leave. Within minutes, they were gone. The bombers were alone, deep in German airspace, defenseless except for their own guns. The Luftwaffe knew the Americans were unescorted. They had been tracking the formation since it crossed the coast. Now the killing would begin. At 11:13, the first wave of German fighters attacked, Messerschmitt 109s, diving from 30,000 feet in tight formations of 4 aircraft, head-on attacks from 12 o'clock high. The classic frontal assault. They closed to 300 yards before firing. Orange tracers arced toward the formation. 20mm cannon shells flashed and sparkled as they hit. The fighters fired for perhaps 2 seconds, then broke away, rolling inverted and diving under the bombers to avoid collision. The first B-17 went down at 11:15. A Messerschmitt's cannon shells hit the No. 2 engine on the left wing. The engine exploded in a ball of fire. Flames spread along the wing. The wing structure weakened. The wing snapped off at the root. The bomber rolled inverted and spun down, tumbling end over end. Crewmen tried to bail out, but the G-forces pinned them inside. 4 parachutes opened. 6 men went down with the aircraft. The attacks continued in waves. One formation of Messerschmitts would attack from the front. Before the bomber gunners could recover, another formation would attack from the side, then another from above. The coordination was perfect. The Luftwaffe had practiced these tactics for months. They knew exactly what they were doing. More bombers fell. Some exploded instantly when cannon shells hit bomb bays filled with high explosives. Some caught fire and slowly fell from formation, leaving trails of black smoke. Some simply broke apart in mid-air from structural damage. The sky filled with falling debris and parachutes. The bomber formations tightened to cover gaps left by fallen aircraft. This was standard procedure. Close the formation, maintain the defensive box, keep the fields of fire overlapping, but every bomber that fell created a gap that had to be filled. Aircraft had to maneuver to fill those gaps. This made them vulnerable. German fighters concentrated on aircraft that maneuvered out of position. Gunners fired until their gun barrels glowed red-hot. Shell casings piled up inside the aircraft. The air inside the bombers was freezing despite the gun heat. Men fought in temperatures 40 degrees below zero. The attacks were relentless. Wave after wave of German fighters. The Luftwaffe had committed everything to stopping this raid. Over 200 fighters from multiple units engaged the bomber stream. Messerschmitt 109s, Focke-Wulf 190s. Twin-engine Messerschmitt 110s, firing rockets from beyond the range of defensive fire. The Germans used every tactic they had developed. Frontal attacks, beam attacks, attacks from above and below, rocket attacks from long range. The bomber crews fought back desperately, but they were outnumbered and outmatched. At 14:40, after 3 hours of running battles, the surviving bombers reached Schweinfurt. The target. The reason for this nightmare mission. The flak was intense. German 88mm anti-aircraft guns surrounded the city. Black puffs of exploding shells filled the sky. Each puff was a deadly sphere of shrapnel. The fragments could tear through aluminum skin like tissue, paper. The bombers had to fly straight and level on the bomb run, no evasive maneuvers allowed. The Norden bomb site required stable flight for accurate bombing. For 3 minutes the bombers held course while German gunners below shot at them. Anti-aircraft shells exploded all around them. Shrapnel tore through fuselages and wings. More aircraft were hit. More men died. Then the bombs dropped. The aircraft lurched upward as tons of high explosives fell away. Below them, Schweinfurt burned. Massive explosions rippled through the ball-bearing factories. Secondary explosions followed as stored materials ignited. Smoke rose thousands of feet. The target was hit. The mission objective was achieved. Now, they had to survive the flight home. Between Schweinfurt and the German border, more B-17s went down. The Luftwaffe continued attacking. They focused on damaged aircraft, bombers with engines out, bombers trailing smoke, bombers falling behind. The German fighters showed no mercy. They attacked until their ammunition ran out. Then they landed, rearmed, and attacked again. Some Luftwaffe pilots flew 3 or 4 combat sorties that day against the same bomber stream. At 1540, P-47 Thunderbolts appeared diving from altitude. The escort fighters had launched from England and met the bombers as far east as fuel allowed. German fighters immediately broke off attacks when they saw the Thunderbolts. With fighter escort, even partial escort, the odds shifted dramatically. The Thunderbolts drove off the remaining German fighters. They escorted the battered bomber formations back toward England. Some bombers with battle damage could not keep up. They fell behind and went down within sight of the coast, so close to home but not close enough. By 1745, the surviving bombers began landing at their bases across England. Crews climbed out of their aircraft, exhausted and traumatized. Some aircraft had dead crew members still aboard. Some had wounded men who had bled through the flight home. Maintenance crews counted the battle damage. Hundreds of bullet holes. Shrapnel damage, destroyed engines, shattered gun positions. Across England, 291 B-17s had taken off that morning. 60 did not return. Another 17 were damaged so badly they were scrapped rather than repaired. Total loss was 77 aircraft, 26% of the attacking force. 650 men were casualties, dead, wounded, or missing. The mission was immediately nicknamed Black Thursday. It was the highest single mission loss the 8th Air Force would suffer in the entire war. The ball-bearing factories at Schweinfurt had been hit hard. German production reports documented that output dropped 34% immediately after the raid. But those same reports showed something troubling. Germany had stockpiled ball bearings for months. They had sufficient reserves to make up the production shortfall. Albert Speer, the German Minister of Armaments, later reported that within weeks production was back to acceptable levels. Imports from neutral Sweden and Switzerland helped fill gaps. The strategic impact of the raid was far less than planners had hoped. The cost in men and aircraft was devastating. The results were minimal. General Ira Eker, commanding the 8th Air Force, knew the truth that the statistics made brutally clear. Daylight strategic bombing without long-range fighter escort was failing. Not because bomber crews lacked courage. They had proven their courage beyond any doubt. Not because the B-17 was inadequate. The Flying Fortress was a magnificent aircraft. But because unescorted bombers deep inside Germany were dying at rates the Air Force could not sustain. August 17th, 60 bombers lost. October 14th, 60 more lost. Every deep penetration raid cost 15 to 25% of the attacking force. At that rate, the 8th Air Force would be destroyed before it could destroy Germany's war industries. The problem was fundamentally one of range. American fighter pilots were among the best trained in the world. Their aircraft were highly capable, but neither the P-47 Thunderbolt nor the P-38 Lightning could escort bombers to targets deep inside Germany. The bombers desperately needed a fighter that could fly 500 miles, fight for 30 minutes, and fly 500 miles back. In October 1943, that aircraft existed, but was not yet in service with the 8th Air Force in significant numbers. The story of how that aircraft came to be is one of the most important developments of the entire war. In early 1942, the British Royal Air Force desperately needed modern fighter aircraft. Britain was fighting for survival. German U-boats were sinking cargo ships faster than they could be replaced. The RAF needed fighters, but British factories could barely keep up with demand. The British Purchasing Commission approached North American Aviation in California with a straightforward request. Could North American build Curtiss P-40 Warhawk fighters under license? The P-40 was an adequate fighter, but it had significant limitations in performance and capability. It was what the British could get. North American Aviation's president, James Kindleberger, made a bold counteroffer that changed history. Instead of building P-40s, North American would design and build a completely new fighter, specifically to British requirements. An aircraft superior to anything currently flying. Better yet, they would have a prototype flying in 120 days. The British were deeply skeptical. Designing a new fighter normally took years. North American was promising to do it in 4 months. But Britain was desperate enough to take the chance. They agreed. North American's chief designer, Edgar Schmued, assembled a team of engineers and went to work. Schmued was a German immigrant who had come to America via Brazil. He understood aerodynamics at a fundamental level. He had studied wing designs for years. He designed the new fighter around a revolutionary laminar flow wing that reduced drag significantly compared to conventional wings. The wing was thicker in the middle and thinner at the edges. Air flowed over it with minimal turbulence. This reduced drag and increased speed. He positioned the radiator under the fuselage in a carefully designed scoop. Hot air from the radiator actually accelerated through the scoop, creating thrust rather than drag. Every detail was optimized. The prototype rolled out in 102 days. Just over 3 months from contract signing to completed aircraft. It flew on October 26, 1940. The flight test results exceeded every performance specification the British had requested. The new fighter was faster than expected. It was more maneuverable than expected. It had longer range than fighter expected. North American had delivered exactly what they promised. But there was one critical problem that threatened to make the new fighter useless for the one mission that mattered most. The prototype used an Allison V1710 inline engine. The Allison was a good engine at low altitude. It produced over 1,000 horsepower at sea level, but above 15,000 feet, its performance dropped dramatically. The single-stage supercharger could not maintain power at altitude. At 25,000 feet, where bomber escort combat occurred over Germany, the new fighter was dangerously underpowered. It could not compete with German fighters at that altitude. It could not protect bombers. The Royal Air Force accepted delivery of the new fighter anyway. They used it for low-altitude reconnaissance missions and ground attack. The fighter performed excellently in those roles. It was fast. It was maneuverable. It had long range. Pilots loved flying it, but it was unsuitable for high-altitude bomber escort, which was what the 8th Air Force needed most desperately. In April 1942, Rolls-Royce test pilot Ronald Harker flew the new fighter at the Rolls-Royce facility in Hucknall, England. Harker had extensive experience testing the Spitfire. He understood high-altitude fighter performance better than almost anyone. He flew the new fighter and immediately recognized both its extraordinary potential and its critical weakness. After landing, he wrote a detailed technical report to Rolls-Royce management and the British Air Ministry. His recommendation was direct and unambiguous. Install a Rolls-Royce Merlin engine in the new fighter. The Merlin was the engine that powered the legendary Spitfire. It was one of the finest piston engines ever designed. It had a sophisticated two-stage, two-speed supercharger specifically designed for high-altitude performance. At 30,000 feet, the Merlin produced nearly as much power as it did at sea level. The supercharger compressed thin, high-altitude air to maintain engine power. Put a Merlin in the new fighter's airframe, and the result would be an aircraft with long range, high speed, excellent maneuverability, and high-altitude performance. Everything the 8th Air Force needed. Harker's report was perhaps the single most consequential piece of technical analysis written during the entire war. It identified the exact solution to the problem that was killing bomber crews over Germany. Rolls-Royce engineers immediately began testing the concept. They pulled a Merlin 61 engine from a Spitfire production line and installed it in one of the new fighter airframes. The installation required significant modifications, but the basic concept worked perfectly. The first flight of the Merlin-powered fighter took place in October 1942. The results exceeded even the most optimistic predictions. The Merlin-powered fighter could fly at 440 miles per hour at Proidings, 30,000 feet. That was as fast or faster than any fighter in the world at that altitude. It could climb to 20,000 feet in just over 7 minutes. German fighters took 10 to 12 minutes. It was highly maneuverable at altitude. German pilots would later report that it could turn inside a Messerschmitt 109. And most importantly, with external drop tanks, it had a combat radius exceeding 800 miles. That meant it could escort bombers from England to Berlin and back, 560 miles each way. With enough fuel remaining to fight for 30 minutes over the target, the fighter that would change the air war over Europe was the North American P-51 Mustang. In the United States, North American Aviation and Packard Motor Company moved quickly to put the Merlin-powered Mustang into production. Packard was already building Merlin engines under license from Rolls-Royce for other aircraft. They adapted the Merlin to fit the Mustang airframe. The Army Air Forces ordered the P-51B model into full production in June 1943. 2 factories began building them as fast as possible. But production and delivery took time. Aircraft had to be built, test flown, delivered to England. Pilots had to be trained on the new type. Maintenance crews had to learn new procedures. By November 1943, the first production P-51B models began arriving in England in significant numbers. The first unit to receive Mustangs was the 354th Fighter Group. The pilots were initially skeptical. Most had been flying P-47 Thunderbolts. The Thunderbolt was a massive aircraft, big, heavy, tough as a tank. Pilots trusted it. The Mustang looked fragile by comparison. It had a liquid-cooled engine instead of the Thunderbolt's air-cooled radial. One bullet in the cooling system and the engine would overheat and fail. The Mustang looked like it would break if you looked at it wrong. But opinions changed the moment pilots flew the Mustang in combat. On December 1st, 1943, the 354th Fighter Group flew its first combat mission. 16 P-51 Mustangs on a fighter sweep over France. They were looking for trouble. They found it quickly. A formation of Messerschmitt 109s was patrolling north of Paris. The Mustangs attacked. Within 10 minutes, 3 German fighters were shot down. No Mustangs were lost. The German pilots tried every tactic they knew. They tried to turn with the Mustangs. The Mustangs turned inside them. They tried to climb away. The Mustangs climbed faster. They tried to dive away at maximum speed. The Mustangs followed them down and stayed with them. The German pilots could not escape. They could not fight effectively. They could only die or run. On December 5th, the 354th flew its first bomber escort mission. 60 B-17 Flying Fortresses were attacking the port of Paix, Emden, on the German coast. The Mustangs escorted them for the entire mission. 280 miles to the target. 280 miles back. When German fighters tried to attack the bombers, the Mustangs drove them off. The few German fighters that pressed attacks were shot down. Not a single bomber was lost to enemy fighters. The bomber crews could not believe it. For the first time, they had fighters that stayed with them for the entire mission. Word spread through the 8th Air Force like wildfire. There was a new fighter. It could go anywhere the bombers went. It could beat German fighters in any type of combat. Bomber crews began specifically requesting Mustang escort for missions. Fighter pilots wanted to transition to Mustangs. The demand was overwhelming. By January 1944, more P-51 groups were arriving in England. Production had ramped up dramatically. Factories were building Mustangs as fast as physically possible. Fighter group after fighter group converted from P-47s and P-38s to Mustangs. By spring 1944, 14 of the 15 fighter groups in the 8th Air Force flew P-51 Mustangs. The transformation was nearly complete. The arrival of the P-51 Mustang fundamentally changed everything about the air war over Europe. On March 4, 1944, the 8th Air Force launched its first major raid on Berlin, the German capital, the heart of the Nazi regime. 730 heavy bombers, escorted by 800 fighters. Most of the fighters were P-51 Mustangs. This mission had been impossible just 3 months earlier. Berlin was 560 miles from England. No fighter could escort bombers that far and back. Now they could. The Mustangs escorted the bombers all the way to Berlin. They stayed over the target while the bombers made their runs. Then they escorted them all the way home. When German fighters attacked, which they did desperately, the Mustangs shot down 69 of them. The 8th Air Force lost 37 bombers. That was still heavy, but it was approximately half the loss rate of unescorted missions to similar targets. The difference was dramatic and undeniable. In January 1944, Lieutenant General James Doolittle took command of the 8th Air Force on January 6th. Doolittle replaced General Edgar as part of a command reorganization. Doolittle was a legendary pilot and a brilliant tactical thinker. He made one critical change to fighter doctrine that transformed how the air war would be fought. Previously, American fighters stayed close to the bomber formations in tight defensive escorts. Their primary mission was to protect the bombers from immediate attacks. If German fighters attacked and then dove away, the American fighters had to stay with the bombers. They could not pursue. Doolittle changed that completely. Under his new directive, American fighters were free to pursue German fighters anywhere. Aggressively, relentlessly. If a Messerschmitt attacked a bomber formation and then dove away, Mustang pilots would chase it all the way to the ground. If German fighters tried to land at their bases to refuel and rearm, Mustangs would strafe them on their landing approaches. If German fighters were spotted on the ground, Mustangs would attack them there. The mission was no longer defensive protection. The mission was offensive air superiority. Find the Luftwaffe. Destroy the Luftwaffe. Everywhere and anywhere. Doolittle later called this change the most important military decision he made during the entire war. It shifted the air war from defense to offense. This new tactical doctrine was fully implemented during Operation Argument, which became known as Big Week. Between February 20th and February 25th, 1944, the 8th Air Force launched the most intensive strategic bombing campaign to that point in the war. The primary targets were German aircraft factories. The goal was to destroy the Luftwaffe's ability to build replacement fighters. Over 6 days, the 8th flew more than 3,800 heavy bomber sorties, escorted by hundreds of fighters flying offensive sweeps. The Germans had no choice but to defend their aircraft factories. The Luftwaffe threw everything into battle, every available fighter unit, every experienced pilot. They fought desperately because they knew what was at stake. But the situation had changed fundamentally. American fighters were no longer tied defensively to bomber formations. Mustangs swept ahead of the bombers, hunting for German fighters before they could position for attacks. When German fighters did engage the bombers, Mustangs pursued them relentlessly. Luftwaffe pilots found themselves under attack while trying to land with empty guns and low fuel. Their own airfields became death traps. The 8th Air Force lost bombers during Big Week. 97 B-17s were shot down or crashed. 40 B-24s were lost. Another 20 bombers were so heavily damaged they were scrapped rather than repaired. Total heavy bomber losses reached 157 aircraft. These losses were painful. Crews died. But the losses were sustainable. More importantly, the loss rate was dropping dramatically. Big Week missions averaged approximately 6% bomber losses. Compare that to the 20% loss rate at Schweinfurt just 4 months earlier. The difference was the P-51 Mustang and the new offensive fighter tactics. The Germans lost far more than they could afford. The Luftwaffe lost over 262 fighters destroyed and 90 more damaged during the 6 days of Big Week. Even worse from the German perspective, they lost nearly 100 experienced fighter pilots killed. That represented 14% of the entire German fighter force. Pilots with years of combat experience. Pilots who had fought in the Battle of Britain, over the Eastern Front, and in the Mediterranean. These men were absolutely irreplaceable. German pilot training had been cut drastically due to chronic fuel shortages. New pilots arrived at frontline units with perhaps 80 to 100 hours of total flight time. American pilots had 300 to 400 hours of training before they saw combat. The experience gap was enormous. Experienced German pilots were worth their weight in gold. They could teach new pilots. They could lead formations. They could make tactical decisions in the chaos of combat. The Luftwaffe was losing these irreplaceable veterans faster than they could possibly be replaced. The best pilots Germany had were dying in the skies over their own country. The psychological impact on surviving Luftwaffe pilots was severe and deepening. German fighter pilots who had been confident and aggressive in early 1943 were becoming cautious and demoralized by spring 1944. They knew they were outnumbered. They knew the American Mustang was superior to their Messerschmitt 109s and Focke-Wulf 190s in almost every performance category. They knew American pilots were better trained and had more flight experience. They knew that every mission might be their last. Morale collapsed. Between January and June 1944, the 8th Air Force flew over 200,000 combat sorties and lost approximately 2,000 aircraft to all causes. But the Luftwaffe lost over 3,000 fighters and thousands of irreplaceable experienced pilots during the same period. The attrition was unsustainable. The Luftwaffe was being systematically destroyed as an effective fighting force. By June 6, 1944, D-Day, the results of this campaign became absolutely clear to everyone. When Allied forces landed on the beaches of Normandy, the Allies flew over 14,000 air sorties in support of the invasion. The Germans flew approximately 300 sorties. German ground forces in Normandy called desperately for air support throughout the day. None came. The Luftwaffe lacked sufficient aircraft, fuel and pilots to effectively contest Allied air superiority. The few German aircraft that did appear were quickly shot down. The invasion proceeded under complete Allied air dominance. The 8th Air Force's primary mission on D-Day was attacking Luftwaffe airfields across France and occupied territories to prevent any possible German air reinforcement of Normandy. American bombers and fighters destroyed over 300 German aircraft on the ground that day. The handful of German aircraft that managed to fly toward Normandy were intercepted and shot down before they could effect the invasion. The Luftwaffe had been rendered impotent. After D-Day, strategic bombing of Germany intensified dramatically. By this time, bomber losses had dropped to levels that would have been unimaginable a year earlier. Missions that routinely cost 30 or 40 bombers in 1943 now cost 3 or 4. The P-51 Mustang made that difference. Long-range fighter escort meant bomber crews had realistic chances of survival. By February 1945, the 8th Air Force was launching massive raids with over 1,000 heavy bombers escorted by 500 Mustang fighters. The Germans could do almost nothing to stop these raids. The Luftwaffe threw its few remaining jet fighters into combat. The Messerschmitt Me 262 jet was genuinely fast and heavily armed with 4 30mm cannons, but too few jets were produced too late to change anything. Mustang pilots learned to attack Me 262s during their vulnerable takeoff and landing phases when the jets were slow and could not use their speed advantage. Most German jets were destroyed on the ground by strafing attacks before they ever flew combat missions. By May 8, 1945, when Germany finally surrendered unconditionally, the 8th Air Force had accomplished every mission objective assigned to it. They had destroyed the Luftwaffe as an effective military force. They had achieved complete and total air superiority over Germany. They had dropped over 670,000 tons of bombs on German industrial and military targets. They had destroyed oil refineries and synthetic fuel plants, reducing German fuel production to nearly zero. They had shattered transportation networks, making it nearly impossible for Germany to move troops and supplies. They had made the D-Day invasion of Europe possible by achieving air superiority. They had helped win the war, but the cost must never be forgotten or minimized. The 8th Air Force suffered over 26,000 men killed in action. That was more than the entire United States Marine Corps lost in the entire war across all theaters. Another 28,000 American airmen became prisoners of war. Over 4,700 heavy bombers were lost in combat. Thousands more were damaged. These were not just statistics. These were sons and brothers and husbands and fathers. These were young men who volunteered to serve their country and paid the ultimate price. None of this would have been possible without long-range fighter escort. None of it would have been possible without the P-51 Mustang. That single aircraft changed the strategic situation fundamentally and irreversibly. The P-51 Mustang became the highest-scoring American fighter aircraft of the European War. Mustang pilots destroyed 4,950 enemy aircraft between late 1943 and May 1945. That total includes both aerial combat victories and aircraft destroyed on the ground during strafing attacks. The Mustang flew more combat sorties than any other American fighter in the European theater. It escorted bombers to every major target in Germany. It flew deep penetration missions to Poland, Czechoslovakia, and Austria. It flew complex shuttle missions where bombers and fighters departed England, bombed targets in eastern Germany, flew to bases in the Soviet Union, then bombed different targets on the return flight days later. The men who made the Mustang possible worked largely in obscurity and received little public recognition. Edgar Schmued designed one of the greatest fighter aircraft ever built. His innovative laminar flow wing and careful attention to aerodynamic efficiency created an aircraft that was both fast and long-ranged. James Kindleberger made the bold decision to propose building an entirely new fighter design instead of simply manufacturing existing P-40 Warhawks under license. That decision brought the Mustang into existence. Ronald Harker wrote the technical report recommending installation of the Merlin engine that transformed the Mustang from a capable, low-altitude fighter into a war-winning, high-altitude escort fighter. These men and many others changed the course of the air war over Europe through technical innovation and bold decision-making. But the bomber crews knew. Every man who flew deep penetration missions over Germany in 1944 and 1945 knew exactly what the Mustang represented. It meant they had a realistic chance to complete their required tour of missions and go home alive to their families. Before the Mustang arrived in significant numbers, bomber crew survival was statistically improbable. After the Mustang became the primary escort fighter, survival became not just possible but likely. That difference represented thousands of lives saved, thousands of men who came home to their families instead of dying over Germany, thousands of men who lived to raise children and have careers and grow old. The 8th Air Force won the air war over Europe because leaders recognized when existing doctrine was failing catastrophically and had the courage to find better solutions. They identified that unescorted bombers were dying at completely unsustainable rates. They found an aircraft that could escort bombers anywhere in Germany. They changed fighter tactics from defensive protection to offensive air superiority. They produced the Mustang in vast numbers. They trained pilots effectively. They used overwhelming force to achieve total air superiority over the most heavily defended airspace in the world. By May 1945, the Luftwaffe was completely finished as an effective military force. The 8th Air Force had accomplished its strategic mission. Air superiority over Germany had been achieved. The D-Day invasion had been made possible. German industrial capacity and transportation infrastructure had been systematically destroyed. The mission was complete, done at tremendous cost in lives and aircraft. But done. These stories matter. These men mattered. Thank you for listening.